What's up, guys? In this video, we're going to go over the fundamentals of JavaScript. So what are data types, loops, functions, ES6, template literals, conditionals, and a whole lot more. We're going to go over just a brief overview of all of these different components of the JavaScript language. And we'll use the old syntax in certain portions, and I'll show you the new syntax, so ECMAScript 6, for the most up-to-date best practice when you're coding with JavaScript. Let's get started. So I have the core data types pulled up, and I'll iterate over these and go into more detail here momentarily. But there's basically 8 core fundamental data types. Now, what is a data type? A data type is what a store of value is represented as, right? So if we go down here, like the string for the first one here. So if we go down here and I assign a variable myvar to string, the store of this string value is in the variable itself, right? So we assign this variable through the equal operator, the one operator, the equal sign. We assign it to the string, okay? So this if we did like a type of, so I'll console log, I'll do type of my var. This would represent, this would yield a string data type. So what is the difference between a number and a big integer, right? Because a number is also an integer. So what's the difference? Big int values represent numeric values which are too large to be represented by the number primitive. So essentially, big int would be big int and then your number, right? Whereas a normal number is just a outright number. So the real big difference here is the, no pun intended, is the big int prefix before the number, right? So if you have just a normal number and it's not prefixed by the big int here, then it's a normal number. What is a Boolean? A Boolean is a true or a false. So it's just true or false, yes or no, essentially. And the Booleans are very important because you'll use them in conditional statements. So you'll use them in like a statement like this. So if I do if and then my var equals false, then obviously that's false, right? Because the true value strictly equal to false, and so they're not. True is not false. So therefore this else would run, right? Theoretically. And if you don't understand this, we'll go into this in detail here momentarily. But for now, basically a Boolean is a true or a false. Now this is important because in that if conditional statement, you can actually check and run logic here, or if it's not conditionally met, then you can run your other logic, right? So if I want to check, for instance, and see if input fields are all filled out and they're properly filled out, so no empty fields, then I can actually do all of those checks in here. I can do those checks in this conditional check. And so if they're not, then I can like say notify the user that, hey, you need to fill out the fields, you haven't completed the form, whatever, right? So these checks for the true value are important. Like, for instance, if we move on to, say, an object, if my object, right, and we'll create the object here, my object. Object is basically a structured store of value, right? So it has key value pairs, and the key is the first part. So if I do like label and then hello, the key is the label, and then the value is the assigned value to that key. Okay? So, and objects can have nested objects within them, right? So I could do like another, and then I could actually nest another object in there, and another, and so on and so forth. And you can actually store other data types in these as well, like arrays and things of that nature, which we'll go into those here in a little bit. But if I had like another value, key value pair, and I wanted to do an array with 1, 2, 3. So as long as the syntax is proper, you can put booleans in these. So I could do like label to true, things of that nature, right? So as long as the syntax is proper, which you need a comma after every key value pair. So you can see there's comma here, no comma here because that's the end of our object. And the object opens with these curly brackets. So an object opens and closes with these curly little brackets right here, the same as you would use in a function. And so let me remove those. And so the key with the conditional statement, right, the reason why we're making this object in the first place is, say I want to check and see what this label says in this object. So I could do my object, and then I could target the label key value pair with dot notation. So the dot and then label, and if that equals high, then we want to run our logic, right? Which obviously equals hello. It's equivalent to hello, not hi. So it's going to run the else logic, this chunk right here. And that's why conditionals are so important, and we'll go into more detail. But that's the object format. We've covered null, we've covered undefined, covered booleans, integers, and numbers and strings, right? So now we just need to cover the symbol. So what is a symbol? A symbol is a built-in object, so it's kind of like what we just described here and just iterated over. It's an object whose constructor is a symbol or returns a symbol primitive, also known as a symbol value or just a symbol, right? So what does that mean? What does that look like, right? So we'll do my symbol equals, and it's basically prefixed with the symbol, and then I could use my var in there, right? So this would be a true value because we're passing that variable into this. And that's basically it's just a unique identifier for an object, essentially, right? So it's an object, but when you conditionally check, it yields different results and more specific results because each one is very unique and has a unique identifier. So whereas if we did JSON parse and then or JSON stringify and compared my object equals my object, and if we would have to JSON stringify these, which that will make it into a string format, that would return true because these are indeed equal when they're both in string format or whether they're parsed, right? So, but if we took my symbol and we did that, we would have different results. They would not be equal and they would run else. So that's the difference with the symbols. It's basically an object with a unique identifier. Okay, so now we're going to go over variables and variable declarations. So var, let, const, etc. All right, so we're going to start with the older syntax. So not ES6, which let and const are ES6 syntax, right? So it's the latest, greatest, best practice, basically. So the let and const mean the same thing as var. Well, let does. Const is the same thing as let. However, with const, you cannot redeclare. Let you can redeclare, and var you can redeclare. So let is about the same thing as var, and const is the same thing as let and var, but you just can't redeclare. So if you have a variable or something you want to assign that is not going to change, that you will not allow to change, or that you want to strictly equal something and never change, you would use const. And if you want to just declare a variable that may change in value over time, say through a loop or something like that, you would use let. And that's the equivalent of var, it's just the new version. So let's jump in. I'm going to create a variable called my variable, and I'm going to assign that to true. Okay? So this true value is assigned through this equal operator to the myVar variable name. Okay? So I could do myVar equals false, and then if I console log this, myVar equals true or false, oops, and then I log that myVar, and save this and run this in the node environment, we'll see that our variable started as true, but it ends as false as we redeclare it here. So let's go ahead and give that a run. So I'm going to go into my terminal, and I'm going to go node index.js, which index.js is my file right here. I'm in the fundamentals directory. And then if we run that, we'll get false, as we redeclared our variable to false when it started as true. Now, I want to show you guys something. So if we do const my var, it's going to give us an error because we can't redeclare that, because once you declare something with const, it's no longer redeclarable. It's only declarable once. So let's give that a save and run that, and we'll get an error. And here we go. Assignment type error, assignment to constant variable. So you cannot reassign those. Now, if we did let, which we did var earlier, you will see that let is the same exact thing as our first ones, right? So the two commands ago, so we get false. All right. And now we can also, we could keep redeclaring this. So we could do my var equals string, and then my var equals we'll do null. So now when we log this down here, we'll get null. So I'll just take that out. We'll run this again, and we get null, right? Okay. So that's the variables. This is just telling the variable name what it should do, right? So if it's const, it should not allow redeclarations. And then if it's let or var, which you should use let because that's the best practice, right? So that's the latest declaration syntax for a variable, whereas it used to be just the var, right? So typically you'll use let for most things, but like function names, right? If I want to create a function and call it my function, and this is the old syntax, right? So, and just follow along. You don't have to do this in your own editor. Just follow along and you'll understand. So if I have function my function, I can actually reassign this function to something else, right? So I could maybe, if I declare this, right? So I could do let my function equals my function, and then so let's log that. I'm going to get rid of our redeclarations there, and then we're going to return just any value, so just true. So if I call that, or I don't need to call that because the function, we'll run that as is. I don't need to call that. It's just going to show the function itself, not the call. So it's not going to return the Boolean. It's just going to return the function. So there we go. So there's our function. And then if we call that, we can do a self-invoking function there at the end and actually get the Boolean value. So true. Now, if I do say I reassign this function, right? So say I do my function equals false. Well, we just saw that it does indeed equal true when we call that function. So it's basically running this, executing this code block, and it's a self-invoking function, and then it returns the value true, okay? But then we're reassigning it here to false. So it should say false. So let's give this a save, and then let's run that again, and there we go. We have false. So you can reassign, because basically this function runs, and it returns true, which is then assigned to the my function variable. But then we reassign it here, and so yeah, that gives you an idea. But if we do const with this, right, it'll do the same principle. It'll show us that we cannot redeclare, okay? So pretty much you only use const if you're creating a function or you are assigning a global value. So and we'll go over lexical scope here momentarily. But if you're assigning a global value versus a local value, local values are typically let and global are const. So we'll go over that here right now, and let's jump to the next section. That is the fundamentals on the var, let, const, variable declaration. All right, so what is local and global scope, you may be asking? Let's create a function, and so I'm going to create a ES6 function, and I'm just going to call it my function, and then I'll assign that to nothing, and then I'll just open those brackets, okay? So what is a local scope, okay? So if I have a variable out here, and I'll call it num4, and then I have a variable let number num2 equals 6. This number 2 cannot be accessed outside of that function. It's only accessible inside the function, whereas the num4 is outside of the function, so it can be accessed both outside and inside of the function. So I could do like num, and if I log that and then I run that, we'll get 4. So you can see down here we get 4. Let me zoom this in. Sorry about that. So we get 4, okay? But if we go back and we try to log the variable inside the function num2, then it'll give us an error because that's not an accessible variable within where we're console logging, because we're console logging outside of the lexical scope of that function. So let's give that a save and give it a run. And you can see num2 is not defined because it is defined, but it's defined in our function. So if I move this inside the function, then we could console log that. And you'll see that lit up, so in the text editor, so it registered. However, you might be thinking, okay, yeah, that just should console log it, right? But nothing's going to happen because we're not calling this function. So if I go up, nothing happens. So we need to call that function, and then we'll get that console log. And now we'll get 6 because we're targeting num2, right? So if we console log that, we get 6. So lexical scope is basically, you have your global scope, which is outside of this function, and then we have our local scope, our number 2, inside of our local scope. Okay? So scope is basically the range, the field where you can access values and related functionality. So what are functions? Functions are another store of value, but they're not only a store of value, but they process logic within their scope, their local scope. Okay? So a function can do a wide array of things. You can have an empty function that's called myfunc that just returns a simple value, a string value of string 2, right? Or you can do complex things. You can I mean, this isn't complex, but you can do a for loop, and we'll do index, and we'll pass that array into the function, and we'll call that function myfunction with a array as the argument or the parameter that we're passing to our function, and then we can return that element. So this would return 1, 2, 3, 4, 5, or if I console logged it, we'll just do that, console log element, okay? And this is not complex, but for the sake of learning, this gives you an idea of what you can do in functions. So like if I wanted this function to add the sums of these nums, okay? This is a good principle, a good way to explain the global scope as well. So notice that our function is globally assigned, okay? And then I could do let sum equals 0. And then in this function, we could do sum plus equals element. So it's going to do sum equals 1 plus 2 plus 3 plus 4 plus 5, right? So we should get 15 from that. And then outside of the loop, we're going to do console log sum instead of element, okay? And so for this one, we just want to add the sums. That's the whole purpose of this function. Each function should have a specific purpose and in rhyme or reason to its existence. So we should get 20 here, or sorry, 15, and we get 15. So we have our sum, right? And now I could do other things with these functions. I could do something very simplistic as just return a value, right? Or I could calculate the age of someone's birth date, right? So if they were born in 70s, I could calculate whatever the date is. I can add dates together. I can subtract dates. I can call other functions in this function. So like, let me give an example. So I'll create another function, secondary, and then we'll pass a value to that secondary function, a parameter. And a parameter is basically a value that you pass to it, right? So see, we call the function here, and I pass this array of numbers to our argument, to our arguments, and then that then becomes accessible in the function. Okay, so if this was empty, that would not be accessible. We have to make that accessible by passing it through the arguments or parameters, and that's typically in the first parentheses. Okay, so secondary, so I'll return the value, and then we can call this secondary, and I can do like we'll do an example. Sorry guys, we'll do an example. Let sum equals 111, and then we'll do sum plus equals, and then we'll call secondary, and then we'll pass it a value of 10. So we'll have 121 if we return the sum. Now, mind you, in your functions, you have to return the value to get the value. So let me console log that out and call this and console log this. So we'll do console log add the sums, and we're not going to pass any values in this example. So, and we're not going to get anything from this. We're just going to get undefined, right? So see, nothing's defined, no value returned. So you have to return the sum with this return operator, or this return, I don't know the technical term for it. I'm blanking. I think it's an operator. But yeah, you have to return the value somehow. So in every function that you want to give a value, make sure you return it. And so I'm going to save this, and now we should have 121. And you can see down here 121. Because what it's doing is it's taking our secondary function, we're passing it the 10 argument or value, and then it's adding that to the sum, which is already existent in our inner function. So you can use functions within functions, within functions, within functions, and etc., right? So a function is basically, it executes logic in an orderly manner. You don't want to do like let, never do this, because you can then accidentally reassign your function to something else. So if I like later in my code, I forgot I named this variable add, right? And then I had another variable called add, right? That's conflicting, but say the project's massive. The file's a large file, 1,000 line file, or 2,000, whatever it may be. Then what I could do is, or better example, let me get rid of that one. So like let add, and then I could do add equals something. And thinking that I'm actually targeting another variable, but I'm actually reassigning that function. So every time I call that function after that, so if I do add, that's going to give us an error actually, because it's reassigned. See, add is not a function because we reassigned it. So if we console log the add, then we'll see it now says something, okay, right there. And so that's why you want to use the const, because if I try to redeclare this, it'll give us that you cannot redeclare error. Cannot redeclare to a constant variable. Always, always, always name your functions with the const prefix. So I briefly covered loops a second ago, but we're now going to review what loops are and what type of use cases you'll have them in, or you'll use them in. So a loop typically looks like this. So you'll have for, and then you'll declare your initial variable. So I'll call it I equals 0, and then you'll increment it as long as it's well, now we need an array, right? So I'll create an array. 1, 2, 3, 4, 5, 6, 7, 8, 9. That'll work. And so we're gonna iterate as long as I is less than array length. Whoops, array length. And I will increment by 1 each time. So what is I? I is the index. So not the number, not these numbers, but the actual index. So if we wanted to target the number itself, we would have to go const L element equals array, and then the index that is currently selected in that loop. Okay? So that would, like, let me show you an example. Let me just log this. And so we'll see these numbers all logged line by line, because it does one at a time. It iterates over the array. So it'll basically go like 1, 2, 3, 4 as it iterates through the array. Now this could be like an array of objects, could be array of whatever, right? You could have different values in the array, like an object, a false, a true. And I'll do this as an example. We'll just log that. So let me go into my terminal and I'm going to run that. You can see array is not defined, so I didn't define that properly. Oh, I named it R, so we need to give it the full array name. And let's go back. And now we'll see our different items iterated through and logged line by line. Now, mind you, JavaScript is single-threaded, or it's like it goes line by line, right? And that's where async and await comes in, or asynchronous behavior. But for now, don't worry about that. It's synchronous, right? So it's operational line by line, and that's why we see 6 different lines here. It's iterating and over each one and logging each one. So how does a loop work? You basically set it a initial value. So in this case, I have I equals 0, and then as long as I is less than the array length, which the array length would be 9. So if we log that, we'll do array length, and let me get rid of that console log element for clarity while we're debugging this. So you can see we have 9 here, okay? And so the array length is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And as long as I is less than that value, keep incrementing the value by 1. So plus plus is basically plus plus 1. So plus 1, plus 1, plus 1. Whatever the number value is, increment it and add 1. So yeah, so we're going to loop through this array and keep adding to that value until it is less than, greater than the array length value. And that's why we get that 1 through 9. So if I console log that again, we'll get the 1 through 9 and then the 9 itself. The 9 is the array length. So loops are basically a way of iterating over an array, but you can also iterate and loop over objects. So how would we do that? Let's create an object, my object, and then I'm just going to assign it random values. So label something, some label value to num 55 boolean true and enter as an object, okay? And so how would we loop over this object? Same principle with the loop, it's just different syntax. So we're going to do for and then open brackets, and then we're going to do let key, and the key is the key value pair, right? So the key value, and that let the key in, and then we bring in our actual object name, my object. And then so if we do const, because I want to keep these values the same, and then we'll do my object, and then we'll target that key value pair with the brackets. And if we log this, we'll actually get each one of those. So if we log this, we'll get the key. I'll do the key and the value. So the value we assigned as well as key. And that'll give us each item in our object. So let me do this real quick. And there you go. So there's our object that we just created. And you can see the different key value pairs. So what are operators? Operators are, there's a whole lot of different types of operators, and they're basically, you have like comparison operators, arithmetic operators, assignment operators, comparison operators, string operators, logical operators, and so on and so forth. And so an operator can be used, like if we have a check, a if statement, I could do like, I could create two variables. So I'll say let A equals A, and let B equals B. So if I wanted to loosely compare these, I could do 2 equal signs and then A equals B. So the loosely equal right here, that's a comparison operator, whereas we have the assignment operators above when we're assigning the value 1 to A and 2 to B. So what are arithmetic operators, or arithmetic operators? I'm probably butchering that. They're basically when you add, so like if we want to do A plus B, right, and then we do a conditional check, it strictly equals 3, well, that would indeed strictly equal 3, okay? And this plus sign right here is the arithmetic operator. So let's go over all the operators, and so we'll make a brief list of these. So we have the plus operator, which adds the values. We have the minus operator, which subtracts values. We have the multiplication, which multiplies by the values. Then we have the division operator, which divides. Then we have the division remainder, or the modulus operator, which basically is the remaining value after you calculate a divide. And then we have the plus plus, which is increment by 1. Then we have decrement by 1, which is minus minus. And then last but not least, we have the times times, and that's basically exponentation. So the exponent, or timesing, like basically timesing by the number itself. And then that should be, I think, all of the main basic ones. And these are all different operators for comparisons, for manipulation, for subtraction, addition, like manipulating data, basically. Now, mind you that these are arithmetic operators, these guys right here. So those are the only operators that are arithmetic, and we'll cover the other operators here momentarily. So let's go over comparison operators now, and I'll make a brief list of these as well. So we have loosely equals to, which is not strictly. Then we have strictly equals to, so it must be exactly, not just close. And then we have is not equal to, loosely. And then is not equal to or not equal to type. Oops. So this is the one you'll typically use if you want to check not equals. And then you have greater than, less than, greater than or equal to, or less than or equal to. So like say you're in a loop, you want to check and see when the loop exits, you could do greater than, less than, equals to, or if you want to check a number that's equivalent to a number or less than or greater than, that's where these operators would come into play. And then you also have the ternary operator, which is basically this operator right here does the same thing as this conditional statement, right? So let me give you an example. So if I do A plus B strictly equals 3, and then the ternary operator, I'll do true or false. And that would be the same as returning true or returning false. So that's the ternary operator. And these are all comparison operators. So we could do like in our if statement, we could do like A plus B is greater than or equal to 3, right? And it is indeed equal to 3. It's not greater than, but it's equal to 3, so that would run true. Or we could do less than or equal to, which is also still equal to 3, and it's not less than, but it's still equal, so that would run true. Now if we do less than 3, that would run false because 3 is not less than 3. So you'll use these operators, these checks and conditionals, these comparison operators, typically in if statements and functions and stuff of that nature. All right, so what are switches and conditionals? We've already gone over the conditionals briefly, but I'll just go back over them. So there's a couple ways you can do conditionals, right? You can use the ternary operator, and if you use that operator, it looks something like this. So if I create a variable A equals 1, let b equals 2, let c equals 3, okay? And then if I want to compare, say I have a return a function, so I'll do const my func, and then I'll just create an empty function here, and then we'll call that function. So we get the results, so it runs the logic on the inside of the actual function. And so now, ternary operator, right? So there's two ways we could write a conditional. So you have the typical if, and then the check, and then runs, and then this runs if true. But you can also do a ternary operator, which is basically the question mark. And so the way you do this is basically, we could do return a plus b, and then if a plus b, so if a plus b with the question mark here, what that separates that, and if a plus b equals 3, then we want to return true, else we want to return false. So it's just like a shorthand conditional. It's a shorthand if statement. So basically, like, let me write one in parallel so you can see exactly what that looks like in both versions. So this would return true, and that would return false. Okay? And so these are identical. These are exactly the same thing. You can see there's more wordage or more length to the longer if and else, but this is more legible. So if you want like a one-liner and you want to be concise, you can use the ternary operators. But do keep in mind that makes it more difficult for other developers to interpret and read your code down the road. So typically I'll use this format if I'm writing in a function or whatnot. But if I'm writing in some inline code, so if like in the JSX, if I have like a fragment and text and then style, this is React Native syntax, but if I have this, right, then that's when I would use a ternary operator because it just goes perfectly with the styles. So I could do a plus b equals 3, and if it is, then I want to do a color red, and if not, color blue. And that's just an example of how the ternary operators, when I'll use them and when you should use them. But if you're just, if you're in a function and you're writing out the code and just you want to have it shorthand or you want to have it, be more concise, then that still has the same function as this, but it makes it more difficult to read for other developers. So just keep that in mind. Now, what is a switch statement? So now that we've covered those two, a switch is basically a if-else. So let me write the syntax out, and then we'll cover this. So case, and then we'll break that loop. And it is a loop. It's like a for loop almost. It'll iterate over each one until it finds a match. That is if you have this in a for loop. But like say I feed a to this switch, it'll check each case to see which one matches. So like I'll show you that in an example in working practice here in a moment. And then you have the default case if nothing is found, and then break. Okay, so we're gonna return nothing string, the string nothing, as the default. And then if a, so like if a, let me set this up, 1, 2, 3. Okay, so we know that a is equal to 1, so obviously this will run. But what it's going to do is the switch statement is going to take the variable that is in this value right here, this value right there, and it's going to check them per each case. So that case, that case, that case, so on and so forth. If it doesn't find any matches, it'll resort to the default case. And notice that we're returning this something, or the nothing, sorry. And so this break does not run because once you return something, it breaks the loop. Same principle in a function. Once you return something, it'll stop executing the remainder of that logic in whatever portion you're at that moment. So like for instance, one we'll do return true, and then we'll return false for the others. So return false, return false. And now if we console log this my function and we run this code, we will see that we get true because A is checking conditionally to see what the case match may be, and the actual case match is 1 because A is equal to 1. So let me give this a save and run this. So if I run this node index.js, we'll get true. And that true is returning from our switch statement that matched the case 1. So that's basically a switch statement. A switch statement will just essentially, a switch statement will go through each case by case, until it finds an appropriate match. And if it doesn't, then it will resort to the default case. So it's a better way of writing if, and then else if, and then else if. It's just cleaner, right? So, and one thing I do want to cover, so you can see the else if. This could go on indefinitely for, this could be infinite, right? But that's how you write another check within a check. So it's going to go, if this matches, then run this logic. If it does not, else if this is true, then run this logic. Else, if this logic is true, run this, and so on and so forth. So, and then at the very, very end, the same principle as we have our default case for our switch statement, we have the else, which returns whatever. If none of these match, none of these cases, then it returns the else related logic. Okay? And so these two are essentially equivalent, this one and that one, but they're just different syntax and different ways of writing. You should avoid these forever going, like the indefinite if else. Those are not best practice. You would want to use a switch statement in a use case like that. So yeah. Thank you for watching, and that was just a brief overview of JavaScript fundamentals. So we went over variables, let, const, var, core data types, lexical scope, so global and local scope, functions, so ES5, ES6. We went over operators, loops, and conditionals and switches. I hope this was helpful. If you liked it, please subscribe or leave a comment. I'll probably post some more courses and educational content if this goes well down the road. So thanks for watching. I appreciate you, and have a wonderful day.